everybody. In this video, we're going to talk about dividing decimals and how you can help your students understand the process of dividing decimals. So when you're first introducing the process of dividing decimals, you want to start by dividing a decimal number by a whole number. So the way you would do this is you would say, okay, let's say we have a decimal number like 9 and 72 hundredths, and I'm going to model these with base 10 blocks. So the 9 is represented by these blue blocks here. And then I'm going to imagine that if I were to zoom in on one of these unit blocks, the zooming in process is going to make the color change. So I'm going to think of it as a yellow block, just so that I can distinguish between the whole numbers and the fractional blocks. And if I cut that big yellow block into 10 pieces, each one of those pieces will be one of these plates. Then if I cut those up into 10 pieces, I get these rods, which will represent the hundredths, because it takes 100 rods to make one of those big yellow blocks. So 9 and 7/10 and 2 hundredths will be represented with these blocks that I have on the screen. And I'm going to divide this decimal number by the whole number 3. And I'm going to say, okay, if I have 9 wholes and I divide them up into 3 equal groups, we know that 9 divided by 3 equals 3. So each group is going to get 3 blocks in it. And we can see that that makes sense because as I'm dividing up these unit blocks and I put 3 in each of the groups, it looks like each group gets 3. And so that means I'm going to put 3 in my answer, and I'm going to subtract the 9 wholes that I divided up, which means that I have 0 wholes left over. And now I'm going to move on to my next place value and divide up my tenths. So I have 7/10 here, and if I put 1/10 in each group, that will work. Then I can put another 10th in each group because I have enough to put 2 in each, and I don't have enough to put 3. And so that means that when I take my 7/10 and divide them up into 3 groups, each group gets 2 tenths. And the tenths that I divided up are 6. There's 6 of them. And I have 1 left over when I subtract those 6 from the 7/10 I started with. And I'm going to take this 1/10 and I'm going to split it up into 10 hundredths. So I have 10 hundredths, then I also have these 2 hundredths. So I have a total of 12 hundredths that I need to divide up into the 3 groups. And we know that 12 divided by 3 equals 4, so I'm just going to go ahead and put 4 in each of these groups. So I already have 2 over here, I won't move those. So I have 4 here, and 4 here. So that means I have 4 hundredths in each group, and when I subtract the 12 hundredths I divided up, I have 0 remaining. And so that means I'm done with my long division process. And that tells me that 9 and 72 hundredths divided by 3 equals 3 and 24 hundredths. And you would want to do several examples like this with your students so that they're used to this process of dividing by whole numbers, and also because it will be a good review of long division for them. And then after you've done several problems like this where they've practiced dividing by whole numbers, then you can move on to dividing by decimals. And a really good way to introduce the process of dividing by decimals is to give your students a really simple measurement division word problem. So remember, measurement division is where you have an amount that you divide up into groups of a certain size and you figure out how many groups you have, versus sharing division is what we did on the last slide, where you have an amount and you split it up into a specific number of groups and you see how much ends up in each group. So this word problem, where Julie has 3.6 feet of ribbon and it takes 3/10 of a foot of ribbon to make a ring, and we're asked how many rings can she make, this would be an example of a measurement problem because we're looking at how many groups of 0.3 can we make. So to model this on a number line, we could say, okay, well 3 and 6/10 of a foot would be right here on the number line. So this is the amount of ribbon that we have. And if we want to make groups of 3/10, then we can just kind of skip count by 3s. So we'd say, okay, there's 1 ring, then 2, 3, and that gets me to 9/10. Then I'll go 3 more tenths to give me my 4th ring, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like she can make exactly 12 rings. And so that gives us the information that 3.6 divided by 0.3 equals 12. So that tells us our answer. But how could we figure this out if it wasn't on a number line or if we weren't using a visual representation of this? And at this point, once your students have solved a problem like this, then you could give them what seems like some unrelated problems. Like you could say, why don't you guys go ahead and figure out what all of these division problems would be? And they'll go through and calculate out, well, I know 36 divided by 3 is 12 because I know my times tables. And if I do 3 times 12, that equals 36. And the other problems might take them a little bit longer to do. But what they'll realize is that all of these problems have the exact same answer. And once they've done that, you can bring back the decimal problem and you can say, earlier we found out that 3.6 divided by 0.3 also equals 12. And what patterns do we notice? And why are all of these answers the same? And what they might notice is that to get from 36 to 360, you have to multiply by 10. And 3 times 10 equals 30. And similarly, if you do 36 times 1,000, that equals 36,000. And 3 times 1,000 equals 3,000. And you could also notice that 36 divided by 10 equals 3.6, and 3 divided by 10 equals 3/10. And so it looks like if you multiply or divide any division problem by the same number in like both parts of the division problem, then the answers will always be the same. And this is the concept that we use when we're dividing decimals. Because if we want to divide a decimal like 4.718 divided by 3.5, that is not something you want to try to do on a number line. And it's also not really something that you can do with sharing division with base 10 blocks because like it's difficult to split something up into 3.5 groups because 3.5 is not a whole number. And so what you would want to do instead is you would want to change this division problem to something that will have the same answer, but will be easier to calculate. So some examples of what you could do is you could multiply both parts of the division by 10, which would give you 47.18 divided by 35. And based on what we saw on the last slide, the answer to this division problem will be the same answer as the answer to the division problem we were given. You could also multiply by 1,000 if you wanted to and do 4,718 divided by 3,500. That would also give you the same answer. And you can let your students decide which one they think would be easiest to solve. And I personally think this one would be the easiest because you're dividing by a whole number, but it's not a really big whole number because dividing by 3,500 is harder than dividing by 35. So if it were me, I would probably use this method and then use long division to calculate it. So that's one way that you can teach division of decimals, and it's kind of the most standard way because it works when you're dividing any type of decimals. And another method that you can also use to divide decimals is to convert them to fractions and then divide the fractions. So for example, if you had 3 and 842 thousandths, you could write that as a single fraction, 3,842 thousandths. And then if you divide that by 1 and 25 hundredths, written as a fraction, that would be 125 hundredths. And in this case, because we have 1,000 and 100, those two numbers are very easily divisible, so you can use the fraction method of division by just dividing straight across. And if you do 1,000 divided by 100, you get 10. If you do 3,842 divided by 125, you get this decimal. And then to find your final answer, you would take this result and divide by 10. So 3 tens divided by 10 gives you 3 ones. 0 ones divided by 10 gives you 0 tenths. 7 tenths divided by 10 gives you 7 hundredths. And 3 3 hundredths divided by 10 gives you 3 thousandths, and so on. And so this would be your final answer. And this process of dividing straight across works really nicely when you have more decimal places divided by less decimal places, because that makes it so you can do 1,000 minus or divided by 100, which gave us this 10. But you can also do it even if that's not the case. Like, for example, if you had 3/10 divided by 5 hundredths, like this. In this case, we would write it as 3/10 divided by 5 hundredths, and dividing straight across doesn't work out nicely, but the zigzag method would still work, because you could go 3 times 100 gives you 300, 10 times 5 gives you 50, and if you reduce the fraction 300 over 50, that equals the number 6. Or you could also think about it as 300 divided by 50 and do the long division, and that would also give you the number 6. So that's how the fraction method works. If you have any questions about dividing decimals, let me know, and I hope you have a great day.